This section is on piecewise defined functions. What's a piecewise defined function? Basically, it's when we take two or more functions and piece them together. And it's just what it says it is. So little pieces of one function and little pieces of another, all on the same graph. So here's an example here of a piecewise defined function. The first one here, x squared plus 1, is graphed right here. This is x squared plus 1. It would look like this. But it's only defined where x is less than 0. So that's why we've got an open dot where x squared plus 1 is equal to 0, and it's only drawn to the left. The second one, x minus 1, is this line. But it's only defined where x is greater than or equal to 0. So where x is equal to 0 on x minus 1, we have a solid dot, and then it's shaded up to the right over x minus 1 because it's greater than or equal to 0. So this first part here just wants us to decide what is y when x is these different numbers. So f of negative 1, that is, what is y when x is negative 1? So x is negative 1 right here. So y is 2. Why isn't it drawing? Okay, don't know why I did that, but there we go. Next, f of 0. What is f of 0? Well, f of 0 looks like it's in two spots, but we can't use the top one because it's open. It's not included. Only this one is included. So f of 0 is negative 1. And then f of 5, what is y when x is 5? You can see here that it is 4. What if we don't have the graph and we need to find these different things? So here we have a piecewise defined function of x squared plus 3 where x is less than 2. 7, so it's just y equals 7, a horizontal line, between 2 and 4, and including 2 and 4. And then greater than 4, we have the line 2x minus 1. So how do we find these? H of 1. So what is y when x is 1? So what we have to do is we have to look at our definitions here and decide where would 1 be. Is 1 less than 2? Is it between 2 and 4? Or is it greater than 4? Well, it's less than 2. So we plug it in. H of 1 plugs into x squared plus 3. So 1 squared plus 3 gives us 1 plus 3 or 4. So h of 1 is 4. H of 3, where is 3 defined? Is it less than 2? No. Is it between 2 and 4? Yes. So h of 3 is, we plug in x, but we can't plug in x. It's just 7. So it's just 7. H of 4, where is 4 defined? Is it less than 2? No. Is it between 2 and 4, including 2 and 4? Yes. So again, h of 4 is just 7. And then h of 5. Where's 5 defined? Is it less than 2? No. Is it between or including 2 and 4? No. Is it greater than 4? Yes. So h of 5 goes into 2x minus 1. That's 10 minus 1, or 9. Let's practice graphing these. Don't look at this and think, oh my gosh, this is too hard. Here's how I like to graph them. I like to graph the functions themselves and then just erase what I don't need. So if you choose to do it that way, please make sure that you use a pencil, because if you've got things marked out on your graph, I can't count it right. So what I'm going to do first is I'm going to graph the 1/2 x plus 1. Okay? Just the 1/2 x plus 1. So the y-intercept is 1. The slope is up 1 over 2. So it would look like this. It is defined where x is less than 2. So basically, everything that's greater than 2, I'm going to erase. Oh, that's a negative 2. So 2, there's 2. Everything that's greater than 2 is going to be erased because it's only defined less than 2. And it's not defined at 2, so I need an open dot there. Okay? And then we'll graph negative x minus 1. That's a y-intercept of negative 1 and a slope of down 1 over 1. So it'll look like this. But it's only defined where x is greater than 2. So I'm going to erase everything that's less than 2. Which is going to be hard to do on here, but we'll get as close as we can. And it's including 2 at this point. So we put a solid dot. And that is the function of f of x. Why do we say it's a function? Because if we draw a vertical line, we only hit it once. Even if we draw a vertical line here, since this is open, it only hits once. So it is still a function. And then we'll graph this function. So the first is y equals 1, or negative 1. Y equals negative 1. Looks like this. It says y equals negative 1 is defined where x is less than 0. So we're going to erase everything greater than 0 and only leave where x is less than 0. And since it's not included, we put an open dot. Next, we're going to graph x minus 1. So a y-intercept at negative 1 and a slope of up 1 over 1. So it looks like this. It says that x minus 1 is defined between 0 and 2. So everything less than 0 and everything greater than 2 needs to go away. It's including 0 here, so we can go ahead and fill in that whole dot, and including at 2. So there's the second part of the graph. And last, we're going to graph y equals negative 2x plus 6. It's got a y-intercept of 6 and a slope of down 2 over 1. Need to make sure. Oh, gotta turn it so I can graph better. There we go. And this part of the function is only defined greater than 2. So I'm going to erase everything to the left of 2 and only leave the part that's greater than 2. And since it's not defined there, we have an open dot. So this is the function of z of x. This next one, we're just going to look at f of x and determine several things from our function without graphing it. So f of 0, back like example 2, where is 0 defined? Is it between -4 and 2? Is it equal to 2? Is it greater than 2? No. It's between -4 and 2. So f of 0 has to be in x plus 2. So we plug in x plus 2, and it's just 2. For part B, f of 2, where is 2 defined? Well, 2 is defined just right here. So f of 2 is, guess what? 2. F of 4. Where is 4 defined? 4 is greater than 2. So 4 goes into our x squared. So f of 4 is 16. D asks us, what is f of -6? Where's -6 defined? Is it between -4 and 2? No. Is it equal to 2? No. Is it greater than 2? No. So that means that f of -6 is not defined. It's not on the graph. Determine the domain of f. Now, that's kind of hard to do without a graph, but if we look at this, we can see we're starting at -4, including -4, right? And we're going to 2, and we're including 2, and then we're going greater than 2. And we keep going greater than 2. It's not stopping anywhere. So it's -4 to infinity. It's including everything between -4 and above. What's the range? And this one is even harder to find. So, to find the range, we need to take our domain, just this -4, and plug in to get y. So -4 is defined in the x plus 2 part of our function. -4 plus 2 is -2. So our graph has to start at -2, including it just as the -4 was included. And since it's not stopping anywhere on the range, it's not stopping in this case for the domain either. And then last, we want to locate x-intercepts and y-intercepts. So find an x-intercept. Well, how do you find an x-intercept? You let y be 0. So where would y be 0? Let's see. We've got to think about, again, our values at each of these. So if we go f of -4, that was -4 plus 2, or -2. And f of 2, that was 2 plus 2, which is 4. So our y-intercept has to be somewhere in between there. So that means that this first piece of the function is where we look for our y-intercept. So we say 0 equals x plus 2. X equals negative 2 is where there will be an x-intercept. So the x-intercept is at the point negative 2, 0. The y-intercept is easier. For a y-intercept, we let x be 0. And where is x defined? Where is x equals 0 defined on this graph? It is this first function. So we're just looking for y equals 0 plus 2, which is 2. So the y-intercept is at 0, 2. For our last example, oh, and there it is. So you can always graph these to double check yourself, by the way. Our last example is taking this and using it as a real world example. Where would we use piecewise functions in the real world? It says a new job offer in sales promises a base salary of $3,000 per month. Once the salesperson reaches $50,000 in total sales, he earns his base salary plus a 4.3% commission on all sales of $50,000 or more. Write a piecewise defined function to model this problem. Okay, and this is where the salary, the monthly salary, is a function of x. Or the monthly salary is a function of the amount of sales, x. So sales is your x value. So we'll say S of x equals. Okay, so what's going on here? Well, his salary is $3,000 if he has less than $50,000 in sales, right? His salary is $3,000 plus 4.3% or 0.043 x if he sells equal to or greater than $50,000. Now let me explain this where I got this x and all that, okay? So it's 4.3% on all sales. So 0.043 times however much he sold, plus his normal base salary of $3,000, okay? And that is if he sells $50,000 or more. And that's it on piecewise defined functions.